Well, hi, good morning. Thanks so much for joining me here in my shop on October 22nd. So it's been a pretty tough year here in Jim's shop. I've seemed to have gone through quite a few difficult radios, some of them really pushing me over the limit. Oh, I wish I had some easy ones to work on, and maybe that's what's coming, but this one here is one of the tough ones. So I worked on this a few months ago and set it aside for a week, and the week has stretched out to a few months, and here it is again. So the story behind this radio, this very nice radio, is it was supplied to me without the speaker. Speaker has a field coil in it. Field coil is part of the power supply. So without the original speaker, I couldn't really plug it in as such. So I powered it using shop supplies and did most of the basic work on it, changing capacitors and whatnot. But then I reached a point during the alignment where I discovered that the two highest frequency bands will not operate. And when I looked into that a little further, there's no local oscillator oscillating on the two higher bands. So I poked around with that for a while. This is a very difficult problem to try to nail down an oscillator that won't oscillate. And I concluded that perhaps it's because I'm powering it from shop supplies and not from its normal supply. It's a bit of a long shot, but I decided I wouldn't carry on with it until I had the speaker, which I have now. I have the original speaker here in a box. So with that speaker, I should be able to operate this set by plugging it in the wall. And maybe if I cross my fingers and click my heels, the two higher bands will start operating for some reason. So this is a very nice radio. I had just finished one very similar to it. It has all these light bulbs here. And when you switch bands, the light for the particular band you're on comes on, and just the strip across the front will light up that you're using. And it's quite distinct. You can see it has these metal pieces here, has ways. These are all separate pieces of glass. Each one of these is a separate piece of glass. This would have been a little expensive to put together, for sure. Look at the size of this dial is huge, and that's a sign of an expensive radio. Of course, you know, back when these radios were being used as a routine thing, you'd be sitting in your nice comfy armchair and kind of lean over and tune the radio. You don't want to get up really close or pull out a magnifier or try to figure out what frequency you're on. So these are also all the shortwave bands spread out. So it doesn't cover all shortwave frequencies, just the broadcast bands, and just a number of them. 1, 2, 3, 4 of them, plus the AM radio band, of course. Potentially a very nice radio, no doubt about it. Some of the things I did, I changed the wire here, I changed the capacitors underneath, and I was able to align a number of the bands. I don't recall now exactly how well that went, but I think it went okay. And then I hit the roadblock of the oscillator that would not oscillate. You can see a fairly old tube sitting here. This is quite an old one. All these metal tubes in here are newer. It's all old, isn't it? Yeah, there's nothing really newer about any of it. But big honkin' power supply transformer, and some sockets that are empty here. So the reason these sockets are empty was I chose, because I didn't have the speaker, there was no reason to have the output tube in place. There's a 6L6 that should be here. And this is the socket for the rectifier tube. You notice again they put the two hot tubes together and off on a corner of the radio towards the back where they would cool off the best. And then this is the plug that goes to the speaker, which I have now. So the next step here, I think, is to prepare the power supply for plugging in, because I ignored it before. So I'm going to flip this radio up. Let me just get out my blocks here. Okay. Now we'll just take a look underneath, kind of remind myself what's under here. This is a very, very heavy radio. Still a little tippy, isn't it? Okay, it's okay for now. I'll make it a little more secure in a bit. Okay, so you see, oh my gosh, lots of capacitors changed up here. Ooh, lots and lots of them. And I have to tell you, it was quite disappointing when this radio wouldn't work on the higher bands. But down in this area is the power supply area. You can see two capacitors here. These are oldie goldies. They are replacements done to get away from. Let me just turn this around here. Well, look at this. So it has these two metal covered capacitors. This one's only 10 microfarads. This one's probably 10 also. Great big capacitors for not much capacity in them. And these guys, I'm going to guess, without studying it further, are replacements for those two big ones. You know, I could be completely wrong here. This is soldered right to the chassis. And hard to say how those got to be there, whether they're original or not. I don't think they are. So I'm going to want to deal with the filter in the power supply. Oh yes, I'm remembering these capacitors. Yes, it's all coming back. The pain of it all is coming back. Fuse, there was a fuse issue here of some sort, which I can't remember in detail now. Good, I have a couple of large wattage power supply resistors, probably part of the power supply, which probably haven't done any duty because I haven't had it really plugged in. Okay, maybe the first, I was going to say maybe the first step is to power it up with shop supplies and see that it works, but there's no reason for it not to be exactly the same as it was. It's just been sitting idle and nothing's really happened to it, so I think I can stay away from that. Okay, just the little things catching my eye. I think the first order of business would be to study the schematic, take a look at the power supply, identify what these capacitors are, decide what to do about it, rather than try powering it up, even with the speaker. These radios that have a field coil in the speaker, and the field coil is part of the power supply. The field coil, the inductor that the field coil is a very, very potent filter. And that's why you find such small capacitors. This one's 8 microfarads. This one is, well, I think it says 0.5, so this is not going to be part of the power supply, I don't think. 0.5? That's pretty much nothing. 200 volts? That doesn't make sense. This one's a 450 volt. So anything that's in the power supply in a radio like this is going to be high voltage rated. 400, 450, maybe 350. These often have very high B+ voltages in them. Well, let's do what I just said. We're going to get out the schematic, I'm going to dig it out, and we're going to have a look at it. Okay, here's the schematic. It's not very good reproduction at all. Maybe I've got a better version, or there's a better one out there somewhere. But for now, I think this is going to do. So what we're interested in is a number of things having to do with the power supply. One of them is this tube. 5T4. I showed you the empty socket. I can't show you the 5T4 tube. Either I pulled it out of the set when it arrived here and set it aside and I cannot find it now, or I haven't found it yet. I mean, that's a better way of putting it. or it didn't come with the set, which I don't think is the case. Whatever it is, I don't have a 5T4, so there's an issue about what to do about the missing 5T4 tube. What could I put in here? We'll get into that down the road. But really, we just want to look at these capacitors that are related to the filtering system. So there's these two here on either side of the field coil in the power supply. And these are the 10. Well, one of them I could see was a 10. I'm looking at the number here. Boy, it sure doesn't look like it says 10 there. But for sure, those two tall metal ones are originals. I'd be shocked if they're replacements. I'm looking at them now. One of them is up on an insulator. So you see how the negative side of this goes to the chassis, but the negative side of this one does not. So this guy is up on an insulator. And what's going on here is they're making available a negative voltage to bias, I'm pretty sure bias the output tube. We follow this line. This is the most negative point in the radio. This line, go up. Oh, what's going on here? I think there's a connection right there. And then it comes over, yeah, right to the grid on the tube here. And the output tube, 6L6 output tube. The part that they've grounded is on the other side of the field coil. There's a voltage drop in the field coil. So this isn't as negative. The chassis and everything connected to it is not as negative. The chassis is used very heavily in a big old radio like this. You can see all kinds of connections to it. So if you think of the chassis as 0, then you'd have to think of this wire as minus something, minus 2, 3, 4, 5 volts, I don't know what, some negative voltage. And that's how they sneak a negative voltage into the radio, by basically running the whole thing a little bit positive on here. These other tubes are going to be biased probably with cathode resistors, but I shouldn't really, this doesn't look to be the case, but I don't really know what's going on. We don't have to worry about that right now. But the important point is one of these capacitors is not on the chassis. Now here's another one. It's connected to the chassis. And I cannot read it. I would guess it says 16, but I really can't read the number there. Let's zoom in a little bit. Maybe that'll help. Well, I don't know. It looks like 2 digits, but I don't know. It looks like 20, and maybe that's 10. I'm not sure. The other one is this one, I think, 25 volts. Fairly large. I think it says 70 here, but again, it's really tricky to read. Oh, I don't think it's going to be. Yeah, that's a cathode. I think this is a bypass capacitor, so low voltage, large size. Are these the two that I looked at underneath the chassis there? One of them is a 200 volt guy, and the other one is a 450 volt guy. The 450 volt one is 8 microfarads. That looks like looks like 800 volts. Maybe it says 500 volts. That says 500. That says 450. Oh boy. So if this isn't one of those two underneath the chassis, then wow. I have another diagram here. A whole bunch of stuff from this radio. Let's look at some of these other pages here. Look at this. Cathode ray tuning light. Can't call it a magic eye because that was, I think, a branded name or something like that. Music, speech, station, range switch. This radio has an automatic frequency control in it, which is an unusual feature. Look what they call it. The Atlas of the Air World Cruiser. Yeah, this would be, I'm pretty sure, a top-of-the-line radio for them. Let's look at the next page here. This is page, doesn't have a page number. Just some general instructions on how to use the radio. Constant use of the International Broadcast Book and of the lists published by newspapers will soon enable you to recognize the dial positions of a wide range of stations. New stabilized band spreading circuits. Stabilized. Okay, let's go on to the next page. Antenna and ground. This is worth reading. Let's just read through this. For this set, the Westinghouse Deluxe All-Wave Antenna is recommended. That's because Westinghouse sells it and wants to make some money. It gives a much better signal pickup on short waves and greatly reduces the noises of man-made static. The electrical interference from automobiles, telephones, telephones today do cause a lot of interference, motors, etc. As an alternative to the Westinghouse Deluxe All-Wave Antenna, 2 single-wire antennas of conventional type are recommended. One for the short waves, 29 to 34 feet long. That's quite specific. The other for the standard broadcast band, 50 to 100 feet long. That's not very specific. In each case, the measurements include the lead-in wires. Just one sec. If I can clear my voice a little bit. And a switch should be provided to go from one antenna to the other as the range switch is changed. The antenna, whichever type is employed, should be located in the open as far as possible from all sources of electrical interference such as power lines, street railways, and house wiring. Street railways are streetcars. The ground wire, only necessary where the conventional type antenna is used, should be as short as possible and fasten security either to a water pipe or to a metal rod or stake driven from 5 to 8 feet into the soil. One of the things about that ground rod is it tends to be a fairly narrow rod, a fairly small diameter rod. That's just, what people want to hammer that far down into the ground. But it's actually the outside diameter of the electrode that is critical in controlling its resistance, its earth resistance. So if you were to drag a larger pipe, you'd be much better off. But I don't know, can you pound it? A 1-inch copper pipe or 2-inch copper pipe 8 feet into the ground? Around my house, you couldn't drive anything more than about 1.5 feet before you'd encounter a large rock. The soil around my house and all over the place here in Ontario is just loaded with stones, rocks, small boulders, gravel, and other stuff. Well, I'm going to have to stop and clear my throat here. Radiotrons. The new type, all metal Westinghouse radiotrons are used in this receiver. Well, I showed you a glass tube. What's that doing in there? A genuine radiotron is undoubtedly the most outstanding example of a quantity production of a delicate precision device ever known. That's probably kind of true. Carefully adjusted and tested at the factory. It gives long and satisfactory service, provided it is handled carefully. It should be guarded against knocks and falls, just as you would guard your watch. Radiotrons should be taken out of the set and tested every 6 months. Well, the reason for that is because that'll help them sell more tubes. Any weak ones should be replaced with genuine Westinghouse radiotrons. Yeah, don't use anybody else's tubes. The instrument label inside the cabinet shows the proper socket location, blah blah. Lamp receptacle. For convenience in plugging in a floor or table lamp, a receptacle is provided at the back of the chassis. This is a bigger deal than you might realize, because houses did not have a lot of outlets in them. In fact, if you go back far enough, this would be not far enough, but you go back further, people basically had one light bulb hanging from their ceiling, or maybe a fixture on the wall, one light bulb. And the way you would power, the new devices that could be plugged in is you unscrew the light bulb, screw in a little plug thing, you're probably familiar with what I'm talking about, and plug your radio in there. But that's your only outlet, and now the lamp is no longer plugged in. So what they've done is they've provided a plug on the back so you can keep your lamp plugged in. It's a selling point from way back then. Hamilton, Ontario. District offices in Vancouver, Calgary, Edmonton, Regina, Winnipeg, Fort William, Swastika. What? Swastika? I don't think there's any place called Swastika in Canada anymore. Toronto, Montreal, and Halifax. All the big cities, and that's just basically a list of all the big cities. Fort William's a little bit, I think the name of Fort William is different now. Very interesting. Swastika. I'm going to have to check that out. Where is Swastika in Canada? I think we know why that name may not be used anymore. There's a wiring diagram, very, very helpful. It's a beautifully done diagram. Of course, Westinghouse was a large corporation. They could afford to have large drafting offices and that. I mean, look, this is drawn just beautifully. That might be handy when I'm trying to hunt down why an oscillator won't oscillate. The position of components could be a critical factor in the oscillators not oscillating at the higher frequencies, which is the real problem I'm trying to face here. And what's this last one? Alignment procedure. Here we are, 5T4, 6L6. Okay, I didn't really discover anything too much there. Well, maybe that wiring diagram. Maybe look at that wiring diagram and look for the two capacitors. Now, I have the good fortune of having the radio right beside me here, so I can just look over at it. So when you look at this diagram, you can see a continuous line right from here going all the way through to here, and another one up here. From here all the way through to here. It's as if they took the edges of the cabinet and folded them flat. The edges, the sides of the cabinet. So this is actually a corner. And so these things are mounted on the front of the radio, and these things are mounted on the back. And the area of interest here is right in. Just double checking. Right in here. So here's the two filter capacitors. Good, we can read the sizes here, but especially if I take a moment. Zoom in a bit. 16 and 30. Now I thought I read 10 on the side. Perhaps those have been replaced. That's interesting. 300 and 450 volts. You can see this one is on an insulating support. Now there's two more large capacitors just soldered to the chassis. See how all these lines are dotted? Everything is dotted here, or dashed lines. That's because this is all up above the chassis. You can't see this from underneath. Just these two holes can be seen. I'm looking over to make sure they can see them. Where are these two other capacitors that are here? In the radio, they are soldered right in this area here, soldered to the chassis. One goes to the long resistor here. Well, that's what this is doing. I'm starting to guess that somebody tried to augment or replace these two capacitors with these two smaller ones that are just in here. That's a bit of a problem. They're both soldered to the chassis. How would that work? The other capacitors, the tall metal ones, they're connected in here. I'll have to take some time and kind of trace this stuff out. Yeah, it's a good chance some repairer in the past grabbed a couple of capacitors and stuck them in a way that he thought would augment the radio. Coming off this insulated one is this resistor, and this, let's call them the two augmentation capacitors. One of them is hooked up to this terminal right here. And it says its capacity is 0.5. 0.5. 0.0, it'll be this one here. You know what? 0.5 200. That's it. It's just way bigger. 0.5 200. Yeah. So this is one of them. Now the other one. Yeah, there's the ground connection right there. The other capacitor is also soldered right on the same spot, and it's connected to here. So it looks like this guy got augmented with an additional capacitor from here to ground, and the value of that one is 8, and this guy is 16. Well, it's possible too that if these two were replaced, or one of them was replaced, whoever replaced it put in a 10 and then added another 8 underneath to get 18 instead of 16. That's a pretty good story. That's fairly believable. We can test these. They're electrolytic, so it's a little tricky to get some certainty in the test in terms of their leakage in that. But it's a snap to replace this. It's really easy. A little tiny capacitor will take care of it. So that's probably where I'm headed with that. We'll abandon this one and abandon the one that's augmenting it here. I'm going to flip back to the cameras just so you can see this stuff for real. Okay, so here's the two additional capacitors. No, this is the additional capacitor. This is probably an original. It meets the description on the schematic. It's connected to this terminal board here. There's the resistor in between. Then this one, you know what that looks like? That looks like a let me get something better to point with here. This will do. So there's clearly a material here, black material. It's not so clear on the video, is it? The camera needs to go a little lower. Let's see if I can do this. Pop it right off the tripod here. That's a little better. Incidentally, if you're watching my videos, well, I guess you are, aren't you? Take a moment and make sure you're watching the HD version of the video. I think in some cases, YouTube may serve up the SD version, and the HD version you can get to if you click the little cog or gear on the screen, the bottom right, I think it is. And you see some things you can do there. One of them is change the video quality, so just make sure it's set to the highest quality. So this is an insulating pad here for sure. It's got a rivet there. It's original. This is the bottom of the capacitor. It may or may not be original. It looks original to me. Up here we also have a plate, but I think that's metal. There you can see, I think there's a rivet right here. So you could obviously unscrew this and stick in a different capacitor and wire it in. I'd never know. So this black wire is simply brought down and soldered onto here. positive wire is going right to this terminal that's just out of the, oops, I'm just moving the, I started moving the tripod to re-aim the camera. Am I a little too close? And then you can see the augmentation capacitor soldered right to the chassis here and coming down. So that's what somebody's done. I think they've replaced this one over here. Let's take a look. Let's take a look at what it says. This radio's just a little unstable. I don't want to. We see a 10, two 10s. And they look identical, don't they? EB91, EB91. Two 10s. And just going to peek at the schematic here myself. What were they supposed to be? 16 and 30. Well, this is way off. Well, I'm going to correct this and make it match the schematic. Almost certainly these were replacements. U.S. patent. Must be an American came in and did it. Now, of course, trade between the U.S. and Canada has always been supreme. I'm sure Americans or Canadians that cross the border, while there are differences certainly in our countries, when you go into stores, everything looks pretty darn similar. Yeah. I haven't been doing that for a while. I haven't been to the United States for a long time now. Well, I think that's the name of the game. I would want to replace this one too because it's old. You know, 0.5. Electrolytic 0.5. Or is it? Maybe it's not electrolytic. It just has that look. Okay, that's the order of the day, I think, or the first step anyway. Clean up the power supply filter capacitor situation. Okay, that's what I'm going to do. Okay, so I managed to find some capacitors. I've got a 22 at 350 volts that can take the place of the 16. I can't, that's a little bigger, but I don't think it's going to hurt. And then I've got a 33 at 400 volts to take the place of the 30. That's fine. And then this is my 0.5. A little bit smaller than the original. That ought to do it though. So it's just sizing up the replacement of the 0.5. Looking at when I noticed it has this information on the edge of it, which is the indication of where the outside foil is. So if it has an outside foil, it has to be just kind of a regular paper capacitor. It's just really big. That's the only thing about it. So these new capacitors don't have a marking for the outside foil. How important it is to take this into account, I'm sure there are situations where it's quite important. The idea is the outside foil is going to act also like a shield. So you would like to have the shield connected to ground. A lot of these capacitors are not going from ground, but this one is. It's going from the chassis here. So I'd like to know which side of this is the outside foil. So I'm going to try to find that out, just to follow along with what's been done in the radio. So this is quite hard to see in the camera. It's hard enough to see with my own eyes. But what I'm doing is I'm holding the capacitor. My fingers would be up against the outside foil, basically. And then I'm sticking one end in, looking. Now again, it's not very easy to see on the camera. I can see the limits of the traces somewhere up in this area here. I flip it over, try again. Well, that's really Not very distinct. Who's calling me? Guess who? There's probably much better ways of doing this. Whoa. I don't know why that's changing so much. Yeah, I'd say this is all pretty bogus here. I'm touching this wire occasionally. I think it's a bogus test. Yeah, I don't think I'm going to be able to figure anything out with this. I had to guess. This one is not the outside foil, and this one is. Wow, okay. Probably going to get some comments on this video. Yeah, yeah, it's not very convincing. Okay, but normally I don't even worry about this. Wow. I think this is the outside foil. End of the words. Outside foil. Bit of a guess. I think I found some interesting stuff to look at here concerning this sealed tight solar capacitor. And these old publications, this is May 1938, the Monthly Digest of Radio and Allied Maintenance, 25 cents per copy. So looking at it, we see a big ad here. Now this is from another company. This is from Sprague, another company whose capacitors, if you're doing this work, you come across them all the time. Look at a full page ad. They're setting new standards for midget condensers. Midget-sized condenser. Guy's got nicer fingernails than I do. There we go. Etched foil, dry electrolytics. Dry electrolytics. Not sure that's what this is. Here's where you save yourself some money. These handy kits will help you avoid plenty of headaches. Wow, this is just this is a great thing. Low leakage, ability to stand high surge voltages, exceptionally long shelf life, unconditionally guaranteed. Hermetically sealed against moisture, yet absolutely protected against blow-ups. The finest, most reliable midget dries on the market, bar none. Midget dries. What are the sizes here? Capacitance. 10, 25, 25, 4, 8, just all those kind of sizes. Not a 0.5 in there. Okay, but that was Sprague. What about solar? It's a funny coincidence. I was looking at these yesterday and I happened to spot these ads. It's kind of odd. Just caught my attention. I'm just looking through these. I like reading some of the ads here. Bill, I'm all worn out. This business gets me down. Yes, it can. What you need is a pair of trim featherweight headphones. They only weigh 4.5 ounces. He's smiling. He's not smiling. That looks like a Morse code key there. But here we are. Solar. Little Giant. Now this is not the same kind of capacitor, but it gives you an idea of what was going on back in 38. That's kind of the age of this radio. Half the former sizes. Full capacity, full voltage protection. Minimum thickness means they fit anywhere. Anywhere. Yeah, I don't think you can fit that in my cell phone. Use this latest advance in the electrolytic art. It's an art. But wait. Here's the full line of solar quality above all capacitors. Unfortunately, the copy's cutting part of it off here. This is a symbol of staunch performance. Staunch performance. Of reliability far more important than momentary price advantage. So these are a little expensive, obviously. Experience, something rather, the hidden factor that makes quality, recommends standardize on solar. Somebody recommends standardize on solar. Get this line. 90% of all radio sets manufactured in this country, that would be the United States, are on our active ledger, which means they're all customers of the capacitor maker. We enjoy the benefit of constant contact with their technical personnel, a real advantage. Well, every other big capacitor maker would have the same advantage, wouldn't they? There's the whole line. Look at that. There it is. Or maybe this one. Or maybe that one. Sealed tight. Solar. There we go. I thought that'd be interesting. It's kind of fun to kind of travel back in time when you're working on these radios and kind of imagine the things that were going on back then. Imagine the people working on this, designing it, repairing it, all that kind of stuff. Just adds to the depth of the experience here. Okay, but I'm not getting any work done. And I'm watching television at the same time as I'm doing this. Yes, many little TV breaks. Okay, so I'm ready to install this guy, and I will do that, and then we're going to deal with the remainder. Actually, this is a good time to test this capacitor since we're talking about it and looking at it. So I'm going to do the leakage test on it. I guess there's no polarity here. It looks very much like a electrolytic style of the paper cover and that, but it's not. If it was, one of these sides would probably be just a metal, the outside of the metal can. But not so here. So the idea of this test is put a little voltage, a little DC voltage on the capacitor, see if anything leaks through it. A capacitor like this in good condition, nothing should leak through it. If nothing leaks through it, the eye that you can see here will look like that when the test is complete. It takes a moment for the charge to enter the capacitor. A small one like this is pretty quick. So we'll see the eye snap closed and then pop open again if it's good. If it's not good, it's going to stay closed. The claim on this one is 200 volts and we're starting with 50. If you can see, it says 25. It says 25, but it's actually 50. Okay, here we go. How good are you? No good at all. No good at all. Good choice to replace it. Now, see those ads? How misleading they were? Of course, they weren't making a claim that 100 years from now this will still be good. They didn't make that claim, did they? No, they didn't. Okay, I'll get back to work here. I'm having fun. Maybe I should just carry on for a moment longer here. So just to highlight the difference, you see this one has a metal end to it, and over here it's an insulated end with a terminal on it, and that's the sign of an electrolytic capacitor, not the least of which it's a solar mini cap dry electrolytic capacitor. There you are, no doubt about it. Okay, get to work here, Jim. Get something done. Okay, yeah, haven't got much done yet. Another issue in doing this kind of thing, changing the, replacing or augmenting the capacitors in the power supply is exactly that. Are you changing them out or are you augmenting them? So a lot of times repair people, certainly in the past, would take a bad capacitor like this and just add another one on top of it, so to speak, to compensate for its loss of capacity and leave the old one in. Sometimes that's worth doing because there's some terminals here. There isn't on this capacitor, but terminals and stuff. But it, can't be any doubt that if you've got a full-size capacitor to replace it, like I do, you should replace it completely. So in this case, there's two wires going to the capacitor I'm about to do. This wire is the ground wire for the capacitor, and this is the positive side. So my capacitor here has small leads. It's not really meant for great big old radios like this. When I can fit it in like that, put the negative lead to ground, I can simply cut the old wire and attach it to here. I can utilize this old wire. It means it's right in the right place. And that way I will disable this capacitor up on top, which I will leave in place. Otherwise there'll be a hole there. And the look of the chassis above will be, it'll look original, or as original as it does now. And that's my plan on that one. So I'm going to do that. Actually do something. Okay, since I'm talking about a lot of basic stuff here, I might as well talk about these wires. So the wire has a cloth cover, and underneath it is some kind of rubbery insulation, maybe rubber, I don't know what it is exactly. I'm trimming it back here. I'm trying to trim it back here. So the wire itself is copper with some kind of plating on it. I don't know what it is, maybe tin, something like that. That's why it's silvery colored, but I'm sure it's copper wire inside. Sitting inside this rubbery material, and just sitting in the environment generally for, how old is this? Going to be 70 years, 80 years? Almost certainly a patina has developed on the surface of the wires, make it very hard to solder to. Now, it's not always the case, but I would guess it is here. So to save myself a little bit of grief trying to solder to wires that don't like solder, I'm going to take a little bit of tin foil and just mess up the surface of these little wires. Now, it doesn't take a lot. Like is often the case, a little bit is a lot more than nothing. That should help the situation. I'm going to try to attach it as close to the capacitor here as I can. So, because it's a positive lead at high voltage, and you don't really want it sticking out in the radio. If I attach it farther away, I'm going to have to put some shrink sleeve on it and stuff like that. It sounds like more work to me. Okay, I cut this wire out just a little bit too short. Let's just bend this down a bit. Oh! It looks like this is jumping up here in the solder. No. Okay, we'll just try to mash that around there. Now, you would hope anybody who's poking around in the back of a radio like this understands these things and knows enough to keep their fingers away from everything, basically, when the radio's operating. Unfortunately, the strands have just spread right out there. But I think it's solderable the way it is. Add a little bit of finger oil to it. Okay, so that's two of them in place, nothing soldered yet. So the one that remains now is this guy here. It's going way over there. The other lead is attached to the outside of the can. Wow, but the can is insulated from the chassis. And there's a couple other wires coming over to it. So they're kind of using the can as a terminal point. Rather, saves on having one terminal out here somewhere to be used. So my best move would be to utilize that same spot for the next capacitor. I gotta cut this out here. Hey, we can test this one. We can test this guy. So I had a shocking experience just now going upstairs in my house. I looked out the window, and for crying out loud, there's snow falling outside. It's 3 degrees, snow coming out of the sky. Very, very light snow. So nothing that's going to accumulate at all, but nevertheless, that's the first snowfall of the year. October 22nd. That means I've got to bring my winter tires down from my shed, get ready to put them on, and bring down my snow blower. Ooh, which I've been hesitant on because, you know, the longer you hold off on bringing down the snow blower, the longer the snow will hold off. That's my theory on that. So I don't think there's any snow in the forecast really. So we have the negative side, and I can just trim this wire and connect it just like I did the last one. I can probably get this fixed in here pretty good. It's a little tight in there, but tight for an old radio like this. Okay, so again, because I'm doing a lot of basic stuff and showing it in detail here, because this is the kind of repair that virtually every old radio needs. And they need their filter capacitors to be changed. I've cut the black wire here, and I hope to hook the black wire up to this, rather than try to solder this right onto here. I'm going to go on the wire. So if you listen very carefully, I'll turn my microphones up a little bit. I'm going to bend this wire, and I just want you to listen to the sound. Let me turn these up. Okay, listen. Okay, so what you should have heard there was the sound of the rubbery insulation cracking and fracturing as I straightened out this wire. Finally, there was quite a strong click there. I could feel it where the insulation really gave out completely. Now there's a kink in the wire right here. Not too important. The cloth cover is pretty effective in itself, and the cloth cover seems to have a long life. But bending these wires is something you want to avoid. And most importantly, wires that are going in and out of the transformer here, these ones here, these big guys, you do not want to make any attempt, there's some here too, to do what I'm doing. Make no attempt to wiggle them. You can kind of measure their stiffness a little bit, which is what I'm doing now. Stiff as can be. So if you start fooling around with these wires, if they crack right up in here and really fall apart, this radio doesn't look like it's that bad off, but some are, you're almost killing the radio permanently, because what are you going to do if the conductor gets exposed right up in here? If you can even tell it's happened. Okay, now I have to work on these. Yep. Work on this wire. Maybe I can just... My tool doesn't clamp the wires quite hard enough. That's why I have to reach in and squeeze the tool a little bit. Oh! Here's a story. When I was in high school, we had tools like this in our electrical class. What a stupid class that was. But anyway, it was a much bigger affair than this. This is pretty simple looking, but it did the same thing. Grab the wire and then pull back. See what it's doing? Grab the wire and then pull the insulation off it. Can you believe I got my finger caught in it? To this day, I can't remember how I did this, but somehow I got my finger caught right inside this thing. And any attempt to release it or do anything, the cutting jaws were coming at my finger. So I had to put my hand up. Teacher! The whole class watched as the teacher held my hand up and decided how to get this tool off my hand without chopping the end of my finger off. And without saying anything, he's studying it this way and that way. He suddenly went boom like that. It just yanked it off. Yeah. Well, there you go. Funny stories from way back when. Okay, I got up. Here, let's do this again. Give myself enough wire. Squeeze a little bit. And there we are. When I was a kid, I stripped wires using a knife. That's all I had. I had a knife. I had a knife and a pair of pliers, something like this. Those were my tools. Not very much. Yeah. So one of my basic philosophies in life is 80% is probably good enough. And I know that drives people nuts who believe in, if it's worth doing right. That other way of doing things. But I'm definitely an 80% guy. So here's part of the 80%. It's hanging here like that. Now really not so good. Really not so good. What could I do here? I could kind of strap it here. I think that might be a good idea. Just get a little tie wrap and just tie wrap it up like this. All these things really take. Not this one. This one I couldn't see when I was doing it. And there's a little wire strand hanging out here. That's hard to see. Yeah, so I think I'm going to strap it up against this one. This one's fairly solid. That'll put it in place. Then I can resolder that connection and make it good. Okay, last part to solder here. Get a much better look at it now. So usually when I'm doing these, I'll solder one terminal to give stability to things so they don't fall out while you're soldering. Then solder the other terminal quite well, and then go back maybe and do the first one again, because I may have done a 60% job on it. So this guy's good. This guy's not going anywhere. There we are. Took a while, but that's okay. So that's going to be the end for today. Just doing. Oh no, it isn't. We're going to test this. We're going to test this guy. This is an electrolytic one. It's a little bit different to test. Electrolytic capacitors are leaky by the standards of a non-electrolytic one. So on this tester, you throw that switch over for electrolytic. And this, of course, I have to be careful here and make sure I put the positive side. Positive terminal is the one in the middle. I've cleverly put the red clip lead in. It's really using my head. And then the black one there. This guy, he claims to be good for 450 working volts. 525 VSP. Volt probably means a pulse or something like that. So 450 would be the rating. Yeah, here it is again, 450. I don't think we're going to put 450 volts on it. We're going to start with 50. This time the capacitor will take a little longer to charge up, so I imagine the eye will close a bit and then come open to some degree. That's how good it is. Here we go. Fire one. That opened right up. Okay, 150 volts or so. Takes time to charge. So this capacitor is not in terrible condition. That's just about open all the way. Let's give it 250. Well, it's not opening all that much now. There we go, though. So I would say this is probably serviceable. It also, I would say, better put that clip back on because the capacitor has a big charge on it, and it's going to disappear. It's going to dissipate. Its internal leak will dissipate it, but it may not be fast enough to avoid me getting a jump. And this device, when you let go of this spring-loaded switch, it puts a short on here to discharge the capacitor. Okay, that's probably good enough. General rule is, short them out as long as you charge them. Careful on these guys, especially a big modern one, say like 1,000 microfarad guy. You put charge on it, then you could do the classic hit it with a screwdriver thing, bang, discharge it. And now you think, well, it's discharged. I saw the discharge. But in fact, the charge will start redeveloping inside because the charge takes time to come out. Because it has to do with the dielectric material in there. So you can get a surprising lift. I saw a guy almost get killed. Not from a capacitor, but from a reel of cable. Because of that exact thing. A reel of communication cable, probably maybe 1,000 meters on the reel, probably more. A huge reel, like those great big things you see on trucks. That kind of length of cable. Communication cable, like a 50 pair communication cable. They separated, the pairs. So they all one side pair here, one side pair there, twisted them up, and stuck. I don't know, 20,000 volts on it. These guys were totally stupid. I was standing off to the side, a fairly new employee, watching them do this. Not willing to to say anything, because who am I? I'm just a young pup. These guys were older. And after they were done, the guy literally took a screwdriver and touched it across the leads that were sticking out, the bundle of leads. Bang! It was a big discharge. Everybody's happy. About a minute later, I heard a guy yell because he'd come over and grabbed them, and they still had not only a large voltage, but they would have had a pretty hefty charge with that much cable on a reel. So how close did he come to killing himself? Closer than he should have, for sure. For sure. I almost witnessed a guy getting electrocuted to death. Okay, a little different than a little capacitor, but ultimately the effect is the same. It's the soaking. You could think of it this way: soaking of the charge into the dielectric takes time to bleed outwards again. Okay, so that's all I'm going to do today. I'm not going to try operating this guy. There's a lot more to go through with the rectifier tube and other stuff. So I'll focus on that tomorrow. Tomorrow we'll probably get this guy operating. And then I'll see if in fact the problem I'm trying to solve, which is the lack of a local oscillator operation on the higher bands, will go away simply because I have the proper power supply operating in there. So thanks a lot for watching. And I'm going to get my snow shovel. Oh no, not the snow shovel. See ya.